Yesterday we started doing the notes over lesson 11. On the warm-up, we figured out which graph didn't belong. There were reasons why all four of them didn't belong, so there was no right or wrong answer. The key thing was that you were able to explain why one of them did not belong. Okay? Then we went on, and in 11.2, we started talking about vertical and horizontal lines. I did that backwards. Horizontal and vertical lines, and how to write the equations for those. Okay? That was a lot of important information. If you weren't here yesterday, make sure you pause this video and get everything written down so that your notes are complete. Guys, we are going to have an open note quiz over 10 and 11 tomorrow. Okay? All right, so flip to the third page. That is where we had left off yesterday. Okay, so the directions here state that we want all the possible rectangles that have a perimeter of 50 units. As you recall, we talked that rectangles, they end up having the same side measurements for opposite sides. So if this was 10, that would make this also 10. If this one was 15, that would make this one 15. We want all rectangles that have a perimeter of 50 units. We talked about that we could take the width plus the width plus the length plus the length, and that had to equal 50. Or another way to write that is take 2 times the width and 2 times the length and add them together, and that would also have to equal 50. We came up with 1 together, so the length of 10, so if I took the length of 10 times 2, I get 20. And if I added that to the width times 2, I get 30. And 30 plus 20 is 50. So what we were in the process of doing is coming up with all the different rectangles that we could possibly have measurement-wise. I want you to pause the video and I want you to just take a couple minutes and see if you can just guess and check various numbers to see if you can come up with some of the correct possibilities. So pause the video, just take a couple minutes and see if you can come up with some of them on your own. All right, so I'm going to put down a few, and there are much more possibilities than the ones I am going to write down. Another thing is, let's say if I write down, let's say I do 12, my length is 12 and my width is 13. If you have down that your length is 13 and your width is 12, that's the exact same thing. Okay, that's just that maybe we took our rectangle and we stood it up. Okay, so don't change it. But if you have 13 up here and 12 down here, that's the exact same thing. All right, 14 and 11 would work. 2 and 23 would have worked. 5 and 20 would work. 18 and 7. 19 and 6. 22 and 3. 4 and 21. And 1 and 24 would also work. Guys, there are other possibilities that you could have had down. These are just 10 of the possible ways, okay? So don't change your answers to match mine. As long as yours add up to a perimeter of 50, it should be good. So now what they want us to do is they want us to draw in our rectangles on this graph. They already did one for us. They did one that has a length of 15 and a width of 10. Notice we had the length of 10 and the width of 15. So we could draw in that rectangle instead. So length of 10 and a width of 15. And they actually want you to draw in the sides of your rectangle. So pause your video and draw in all of these rectangles on your notes. Okay, take a minute, pause your video, and draw in all of those rectangles. Make sure you pay careful attention that over here on the y-axis is our length. So make sure you put your lengths on your y-axis and your widths on your x. All right, so your paper, again, if you had different numbers than me, then your rectangles might look a little bit different, but we should all end up with essentially the same thing. Because on number 3, it says each rectangle has a vertex that lies in the first quadrant. Guys, recall that a vertex is where two lines meet. So notice on all my rectangles, I put a point where my two lines ended up meeting. That's the vertex. It says these vertices lie on a line. They want us to draw in the line. So draw the line that connects, and you can use the side of your binder, draw the line that connects all of these points together. Then it says write an equation for that line. Well, guys, if we write an equation in y equals mx plus b form, what two things do we need? We need the slope and we need the y-intercept, the vertical intercept. So for the vertical intercept, all I have to do is look where this line crisscrosses with the y-axis. And it crosses there at positive 25. Now for our slope, notice our slope goes downhill, right? So that automatically means our slope is going to be negative. You can do one of two things. You can pull out two of these points and calculate your slope, or you can draw in your triangles. If I go from one of these points to the next one, how much does it go down? Well, it goes down one box, which would be a -1, and it goes to the right one box, which would be a +1. So our slope, or our equation, would be y equals -1x plus 25. All right, so we have the equation now, and this makes sense because our line starts at 25, and for each rectangle, it's going down one to the length and adding one to the width, which is kind of getting into question number 4, where it says, what is the slope of this line? Well, the slope is -1. Guys, I'm going to write it as a fraction, though. -1, and then if I want to make it as a fraction, I'd put it over a +1. So then it says, oh, let me back up. We could also, remember, we could also switch where the negative's at. So that would also be the same thing as +1 on the top and -1 on the bottom. Remember, these are the same exact thing. It says, how does the slope describe how the width changes as the length changes, and vice versa? Well, in our table, the length is representing the y values. The width is representing the x values because it's on the x-axis. When we write slope, remember we write it as y over x, right? So over here on top, if we have y, that's going to be our length. And over here, if we have x on the bottom, that's going to be our width. So if we're talking about the lengths of our rectangle, what this is saying is if I take 1 from the length of my rectangle, I have to add 1 value to the width of my rectangle. And we can prove that up here in our table. If I add 1 to the length, I would have to take 1 away from the width to get my next rectangle. The same thing is true here. If I added 1 to the length, I would have had to take 1 from the width. So that's what our slope means. As we take 1 from the length, and I'm going to put y, we add 1 to the width, and I'm going to put x. Vice versa, so that's explaining the first one. Vice versa, as we take 1 from the width, which is x, we have to add 1 to the length. Hopefully you started to see that pattern as you were drawing in your rectangles or finding your numbers. You need to pause that before flipping over to the important information on the back, okay? All right, so the important information is talking about horizontal and vertical lines. We did that in activity 2 yesterday. So if you need to refer back to this page, that's helpful in this information. Remember, horizontal lines are lines that run horizontal across the graph. They have a slope of 0. On all of our horizontal lines, if we were to write down their ordered pairs, the one number that doesn't change in the horizontal lines is the y value. The y value stays the same every time in a horizontal line. What does change is the x value in those ordered pairs. Remember, horizontal lines, they're going to cross the y-axis. So when we write an equation for a horizontal line, it'll always be y equals the number where it crosses the y-axis. So for their example, it says, what would the equation of a line through the point 0, 13 be? So if we had a graph, and this is just a rough sketch, I would go up 0, up 13, and this would be my line. So the equation for that line would have to be y equals, because it's horizontal, and it crosses the y-axis, and it crosses the y-axis at 13. So the equation would be y equals 13. The opposite is true for vertical lines. So for vertical lines, the x value does not change in all of those points, but the y value does. Remember, for vertical lines, it crosses the x-axis. So all of our vertical lines are going to have an equation of x equals the number where it crosses the x-axis. So for the point 7, 0, rough sketch, I'd have to go over to positive 7, up 0, so this would be my line. So my equation would be x equals 7, because that's where it crosses the axis at. All right, guys, I went through that really fast, so if you need to go back through and pause it and re-watch it at any point, please do that. You will have a quiz tomorrow, an open note quiz over lesson 10 and lesson 11, so make sure you have your notes completed. You now need to raise your hand and show the sub your completed notes. He or she is going to hand you the cool down for lesson 11. There are 5 lines. You need to write the equation for all 5 lines. Here's A, here's B, here's C, here's D, here's E. Make sure that you distinguish. I would separate out your equations so that I know which one goes with which. If you just write the equations and you don't tell me which one is which, I'll have to count it wrong. Guys, please be on your best behavior